In this video, we're going to take a look at logging in Spring Boot. We're going to take a deep dive look at something called a logback file, which is how we configure logging in Spring Boot. In a previous video, we covered an overview of logging. Now we're going to jump a little bit deeper. First of all, let me describe the difference between a logger and an appender. A logger is something that gathers logging information from our code. We'll typically start with something called a root logger, which is like the default logger where all of our logging comments go. Think of this just like a holding area. Now on top of that we have an appender. An appender actually takes this logging information from the holding area, and publishes it out somewhere that we specify. Could be a console, could be an output stream, could be a file, could be a rolling file. One of the things that we see most frequently is the rolling file, where essentially we will write to a log file, and then once either we hit a date or time boundary or a size boundary, we'll roll that logging file to a backup and start a new log file. So we'll take a look at some of this in this video and how we can accomplish this. Logging is much better than just doing a system out print line, because system out print line just goes to the standard output and doesn't have the concept of severity level. But severity level is really what's key to logging, because we can use that to filter log details and put certain severe errors in one place and then all other kind of logging information somewhere else. So, logger versus appender. In Spring Boot, we can configure our logging with one of these file names that I have listed here. Logback-spring, logback-xml, logback-spring.groovy, logback.groovy, so on and so forth. So what happens is Spring Boot looks for a file with this name on the class path, and if it finds it, it uses that to understand where the logging information is. There are several things that we're going to see in our logger file. One is we can set up properties, which is kind of like a name-value pair. And then the other thing is we can configure our appenders, as I mentioned earlier. Console appender, file appender, and one of the most common, the rolling file appender. So in this exercise, we're going to set up a couple of different rolling file appenders. One that catches all, and another with only severe, essentially warns and errors and greater. Now, when you look at a logging file, it can be very intimidating because there are a lot of symbols that we'll see. As a matter of fact, when we define a rolling file appender, we'll typically give it a file name. The file name must have a %d in it, and the %d represents a date or time. Once we get a log that goes beyond the boundary of this date or time, it will automatically create a new log file. In other words, we could have a \d and then a year and a month. That means that all of the logs for October will go into one log file, but then the first log in November will go into a new log file dedicated to November. You could do this based on year, month, week, day, even hour, minute, second, as you prefer. Day is usually pretty much a default boundary that we'll use for time. In addition to that, you could have a very verbose logging day where you end up logging a whole bunch of details. So an optional parameter that you can put in the file name is this %i. And that means that you'll get a new log file not just when you hit the date boundary, but also when you hit a time boundary. So in other words, October 18th, you could have one logging file, or you could say, okay, every time we hit 10 megabytes, roll over to a new file. If you have maybe 30 megabytes of logs on October 18th, then you'll have 3 different logging files, because you've hit that 10 megabyte boundary 3 different times. So you have to have the date indicator. You may have the I indicator. And the I indicator just represents an integer, which essentially says which log file is this for the specific day. Now in your file name, if you add a .gz or a .zip extension, it will automatically compress it, which is a good idea, because many times, especially with verbose logging, these log files can get very large. A few other parameters that we can set up in our logback file. Max history means how many historical files do we want to keep. Above and beyond that, they will automatically housekeep. Max file size is used when you have that %i symbol. It says once you go past this boundary of file size, let's go ahead and rename the previous file. And you'll see down below I have a bit more information with min index and max index as well, because it can be a little bit tricky. If our log file is named log.txt, as soon as we hit our max file size, it will back up and become log1.txt, and then everything new will be logged to log.txt. Once our new log.txt log.txt hits its maximum file size, we take the old log1 text, rename it to log2 text. We take the current log text, rename it to log1 text, and then we start a new log.txt. This keeps going, but we can't go beyond the max index. Once we go beyond the max index, it starts just deleting the oldest log file every time it creates a new log file. So this allows us to manage our disk space so that the logging file doesn't end up consuming all of our disk space and becoming a problem of its own. Within a log file, you can specify the format for the output. In other words, when I have a log statement, how is it going to be formatted? So this, if you're not familiar with these symbols, these can be a bit intimidating, but this is a quick dictionary of some of the more common symbols that we'll use when we're deciding our format. This applies to every line in the log file. So in other words, we're describing what you will see in a single line. %d, date of a logging event. %p, a priority. %c, the class name that's doing the logging. You might remember from our exercise, we did loggerfactory.getLogger, and then we provided it with a class name. That class name is what you see reflected in place of the %c in format. %t is the thread that's doing the logging. This is really important because you might find that a log or an error is related to only one thread, and this will allow you to essentially sort the log file and only see the details from one specific thread so you can follow that thread without any clutter from other threads that are unrelated or not causing part of this problem. %m is the message that the user printed or stated in the log file. In other words, if a programmer says log.info and then foo would be the message. And then %n is the line break for the operating system that says, okay, let's go ahead and break to a new line. That will almost always be the last thing that you'll see on a logging format line, and it will almost always be the only thing that you see. You'll only see one of them in the logging file line. Let's go ahead and take a look at our virtual machine. Let's look at some examples. The logging configuration file is something that I consider to be like sourdough bread. In other words, you never just start with an empty document and start typing away. You'll typically start with a template log configuration file that you found from somewhere else. Now, of course, I'll be committing this all to GitHub, and you're more than welcome to use mine in your own application and tweak it as you wish. But nonetheless, here is just a sample log file, one that I found on the internet, and then I tweaked it for our needs, and we're going to continue to tweak it throughout this video. I've created a new file directly under the resources folder in my project called logback-spring.xml. And remember, that name is important because that's what it's going to look for. I pasted in the text from that notepad file that I showed you earlier, and now I'm going to go through and describe it for you. First of all, we see it's an XML file, so it has this configuration section, which is a root element, which means that we can click this plus or minus to collapse and expand the entire document. Next, on line number 4, we see a property. A property is like a variable. We'll have a name and a value. The name here is logs, and the value is ./logs, which is essentially a directory location. Now, you can refer to this variable using $curly syntax as you see here. So you see that we can take this directory and we can use it as a token in several different paths, which is really good because what if that path changes? What if we move it to a different machine, maybe something that's really meant for file storage? Or what if we have a different one of these files for each of our environments? That way, if we have a property, it makes it much easier to configure. Next, we have an appender defined. Now remember the job of an appender. The appender takes the logging data from the logger and it publishes it somewhere. It could publish it to a file, it could publish it to a queue, it could publish it to a database, or one of many other things. In this case, we're publishing to the console, which we're used to seeing in IntelliJ IDEA when we run something, because we can see it on this debug tab. So console tends to be very ephemeral. In other words, we'll publish something there, but we're really just looking at for what's going on right now, because history is going to be off the screen. If it's our IntelliJ here, it's going to quickly roll up. We'll have to scroll to see it. On a command line, again, we'd have to scroll up to see it. So it's really just meant for what's happening exactly right now, without a whole lot of persistence. So we won't tend to put everything in there, just the really important things. You'll notice that there's a pattern defined here, and that's one of the more important things about this appender. The pattern says, how do I publish information? So the %d means date, and it's followed by open curly, close curly in a date time format. So that's how we're going to print things. Then the thread that is logging this command. Keep in mind that Java is a multi-threaded application. We can write applications that have multiple processes going on at once. That can be really tricky to track down a log message because you might have different threads that are posting different things. So by filtering by thread, we're able to see just the story through one exact thread. Now, -5 level means that show me the first 5 letters, at most, of the logging level where this was logged. So info, warn, error, debug, trace. They're mostly short words that are 5 letters or less. Either way, you can get an idea what's going on with just 5 letters. Now the logger, where did this information come from? And then the message that we're logging and a new line indication. So if you take a look at the console, you'll typically see that things fall in that similar kind of format. You notice the month, day, year, and time, and then we have the thread that's doing the logging. Then we have our level, then we have the logger, and then we have the message itself in a new line. So that's what's describing everything that you see here. Console is good, but a lot of times we're going to find that we have to debug something that happened 3 days ago. And we certainly don't want to scroll up and find something from 3 days ago. That's where a rolling file appender works out really well. So here we have a rolling file appender, and what that means is I'm going to write things to one log file. Then as soon as we cross some threshold, either a time, could be an hour, a day, a month, or a size of the file, we're going to take the current file, back it up, and create a new file, and start logging to that new file. So if we take a look at this, we see that it's configured to roll over when the file hits 10 megabytes, and you see here max file size of 10. And when it rolls over, it's going to take the most recent log file and put it here under our logs directory using that property we saw earlier, the logs property, and then archived, and then Spring Boot logger, and then a log message with a date, and then essentially .log. So this will allow us to keep certain backup files for when we need to debug something that happened in the past. And this is fairly common. You might not find out until the end of the month that the books didn't balance. In other words, there's an accounting entry that's off. Well, gosh, that might have happened on the 12th of the month. So maybe you have to go back then and take a look at that accounting entry. Now we scroll down. Those are the appenders. So now we can scroll down and take a look at the loggers. So the appenders publish information somewhere. They're kind of like a DAO. They're writing information to a location. Where the loggers are aggregating information from our program that's running. So we have a default logger here, which is logging to console. And note that it's logging only things that are info or greater. So that would be info, warn, error, fatal. Those would typically be what we're looking at there. And that's important because remember, the console, we just want to take a look at a little bit at a time. So it's saying take the info stuff and log it out to the console appender. Console appender we saw up above, of course. And essentially that's what gives us this look and feel that we see here. But we know that we also want that ability to look back in time and also get a little bit more information that we can search for in a file. So I've created a new logger. Note the logger name com.myplantdiary. This means I'm only going to log or collect information from a class that lives in a com.myplantdiary package. Level trace means we're going to get trace and above, which in other words means we're going to get everything. But now take a look at this. I have subscribed to this, a rolling file appender and the console appender. So it's going to publish both to the console and also to this rolling file. I opened my application, I hit a couple of pages, and I also hit the delete endpoint through Postman, doing a couple things. Some that I knew would work, and some that I knew would fail. If we take a look in IntelliJ, things look pretty similar here because we haven't changed anything. But we certainly can. So we see we have a couple error messages, as to be expected because I was trying to delete something that doesn't exist. But now, if we take a look over here at our project directory, we'll see that there's a new folder called logs. And if I click into that, we'll see that there's a new file called Spring Boot Logger. And if I open this up, we'll see that we have some logging information with debug and error. and these are related to my application. So this is an area where we have a written log written out to disk that we can go through and we can take a look at what has happened historically. So you see even the debug endpoint here, entering delete specimen endpoint. Now let's go back and take a look at our source code. Look at the delete endpoint. And sure enough, you see entering delete specimens endpoint. So you see the log statement that I put there in a previous video. We can now see right here, entering delete specimen endpoint. And then specimen with ID 43 was deleted. This was one that was successful. So if we come back and look again at our delete mapping, specimen with ID blank was deleted. So we'll see that these log messages that we've created here are going directly into this file. Let's take this one step further and say I want a file that only shows things that are really urgent, a file that only shows really big problems. So, or at least something that might indicate there is an issue. And this is a really good idea, by the way. I recommend getting really good at logging because I'll tell you something I've said before, which is in our field, you'll spend more time figuring out something that someone else wrote than you will writing something brand new by yourself. So getting really good at being efficient at reading logs is very important. So I'll change the appender name to severe rolling file, just like so. And then I can subscribe my logger to that appender. In the appender, we need to change the name of the logging file as well. Otherwise, we run the risk of having multiple appenders trying to write to multiple files at once, which is not what we want. So we'll change this to severe logger, and then again, for the archive, severe the severe logger will work for us. Now, how do we tell it that I only want to show things that are important? I only want to show things that are problems. Well, I add a new element here. I'll say filter class equals ch.qos. I make an element, filter class, ch blah blah blah, threshold filter, and then inside of this we say level and warn. So that's only going to show warn and above, which is warn error fatal. Let's go ahead and restart. The application's restarted again, and I just used Postman to try to delete a record that's not there. So you see Postman's giving me a 500 internal server error. Now, take a look at our log file directory. Notice something interesting. We have a new file, the severe logger. Let's compare these two files together. Spring Boot logger, you see info debug, info error, and if you scroll down, you can get a rough idea, maybe a couple hundred lines in this file. Now, let's compare that to the severe logger. Severe logger has one error, unable to delete specimen, and it's likely, no specimen class with 43 exists because I deleted it earlier. And then we see a stack trace. But you see, that's it. We're not distracted by info or debug or trace or any of the others. So that's a strategy that's common to use. Put all the log messages in one file, put only the important messages in the other, and then you can use timestamps and threads to correlate the two together. One other important thing I want to point out is that we can specify a level on the logger. As you see here, this is our root logger, and it has level of info. Our logger that we made just for plain places stuff, I put on a level of trace. We can also specify logging at the appender level. So remember, logger aggregates the messages, the appender prints the messages out. Now, here's a thought. If we have a logger logging at info and above, which is fairly high, right around the middle, and we have an appender that's set for trace or debug and above, where trace and debug is going to include info and above and a whole lot of more trace and debug messages. Which one wins? In other words, can the logger be more restrictive than the appender, or can the appender be more restrictive than the logger? Well, if the logger's not aggregating it, the appender won't know that it's there to publish. So if the threshold level on the logger is higher than what it is on the appender, then it's going to go with the logger's logger level. Sorry, that's really hard to say. If the logging level on the appender is more restrictive than the logger, then we're only going to see what the appender says. So basically, we can only see a message if it's permitted at the logger's level and it's permitted at the appender's level. If it's not permitted at either of those levels, we will not see the message. So that's a look at logging. I know that's not a big thing that you think about when you think about programming, but I will tell you, you'll spend a lot of your time in log files like this. So it's really worth knowing a thing or two about it. So with that, I sure hope this video has been helpful, and I look forward to reading your comments. Thank you.